Here we go. Let's talk about Chapter 1, Basics. Here's our outline for today. First, we'll talk a little bit about why we want to learn to program in the first place. Hopefully you're already motivated, but maybe this will give you a little bit more motivation. Then we'll get into some basic computer concepts. We'll talk about what a computer is, what computer hardware is, what computer software is. Then look at data representation, how numbers and things are stored inside the computer. Talk about programming languages, since that's what the rest of this course will be all about, in particular one programming language called processing. And then we'll talk about problem solving. So, why do we want to learn how to do this in the first place? Well, it's a little bit obvious. There's computers all over the place. The rearview mirror in your car probably has a computer in it, and somebody has to write the instructions or the programs that all those computers run. So that means that there's a very practical reason, a great job market for developers now and in the future. If you want to go out and get some statistics that back that up, go to the website code.org and they'll help you quantify that. They'll talk about all the different opportunities that there are going to be for people that can program now and in the future. Also, software development jobs pay pretty well, so you earn a good living doing it, and it's quite interesting work. Beyond the practical reasons, though, there are some other reasons that are a little bit less easy to quantify, some abstract reasons. Learning how to program actually helps you with your problem solving. That's probably not a surprise. Abstract thinking, same thing. But also communications, research, and teamwork skills, because usually programs in the real world are written by teams. And so as you work in a team, you have to hone all those types of skills. I think perhaps the biggest reason, though, is programming is fun. It's just a fun thing to do. There's something really enjoyable about making inanimate objects obey your will. And that's what programming is all about. We're making a machine do what we want it to do. And so it's very interesting and satisfying. And hopefully, as you start programming and processing, you'll enjoy it as well. And that will be enough motivation to keep you going. All right. Well, what is a computer as we move a little bit more into the content of the chapter? It's pretty obvious that you know what a computer is, otherwise you wouldn't be watching this video. But let's get a little bit more specific. Here's a definition from dictionary.com. A computer is an electronic device designed to accept data, perform prescribed mathematical and logical operations at high speed, and display the results of those operations. Okay? So now if we parse that out a little bit, we can get more specific and talk about some details. So before we do that, though, it's kind of interesting to note that once upon a time, a computer was actually a job description instead of an electronic device. So if you were a computer, what you did is you used a slide rule and tables and you calculated results all day. So you computed numbers yourself. Nowadays, though, a computer is an electronic device, and so we can talk about the parts that make up a computer. So first of all, the hardware. The first part of that dictionary definition says that a computer is an electronic device. Okay? So device means it's physical. The physical parts of the computer, the stuff you could kick, which really isn't recommended, by the way, that's called the hardware of the computer. And real briefly, we'll just take a look at some of the major components of a computer, the major pieces of hardware. The central piece, or the chief piece, the most important piece of the computer, is the CPU, or the central processing unit. That would be the brains of the machine. That's the reason that the computer exists. Everything else is designed to support the CPU. And it follows a particular cycle. It has a storage area someplace that has data and instructions. And so it goes out and it fetches the next instruction, the next thing it's supposed to accomplish from that storage medium, decodes that instruction so it understands what it's supposed to do, executes its instruction, and then stores the result back to that storage medium. And it goes through that cycle billions of times a second. So it's very fast, follows instructions. But some of the other parts that we've mentioned in there are things like storage. Where does all that information come from? Well, there are a couple of options for holding data and programs. The first one is what we call volatile storage. That would be fast storage, so we can get information out of it very quickly, but relatively speaking, it's small and pricey. And also, if we turn the computer off, it loses its data. So nowadays, your volatile storage is implemented via what's called random access memory, or RAM. And that's a picture of a RAM stick, a memory stick, for one of the computers in my office. Okay, so this is temporary storage where we hold programs and data that are actually running. For more long-term storage, we have non-volatile storage. So that's generally speaking cheaper. It doesn't lose data when you turn the power off, but relatively speaking, it's slow. So it's slower than RAM. And nowadays, this is usually implemented with a hard disk drive, or HDD. Okay, so that would be where you store all the programs and data and MP3s and movies and games that you're not actually using at the current time. All right, so two types of storage: short-term and long-term, volatile, non-volatile, RAM and hard disk. Obviously, there are other options, things like DVDs, flash memory, things like that. But generally speaking, they still fall into volatile and non-volatile categories. What else do we have with hardware? Well, we've got our output devices. So these are designed to get information out of the computer so it can be used by the user or seen, reacted to in some manner. And our most obvious example would be the monitor. Clearly there are other examples, things like speakers, printers, the rumble motor in the Xbox 360 controller. Those are all output devices that somehow get information out of the computer. Also, we have input devices. Okay, and these are designed to get information into the computer from the user. And here our most obvious example would be the keyboard, thing that we type on to send information in. Some other examples would be the mouse, obviously. Microphones would be a good example, and maybe all the buttons on the Xbox 360 controller or the motion sensing pieces in the Wiimote. Those are all examples of input devices with computer hardware.